Grab a package there, Wayne. Do I need to send another email home, Wayne, about you being late to class? Really? Okay. So remember, Friday morning is your test, your final exam. That's a week from today. That's different than what's on the exam schedule. So make sure that maybe put it in your phone as a reminder in your calendar so you don't forget. Next Thursday is the last day for you to hand in any missing assignments. Okay, so if you have a bunch to do and you're missing, and you don't have some of them, maybe let me know today. And if I get a chance to get them together for you, so you can work on them over the weekend, that would be a good thing to do for sure. But Thursday is the last day for you to hand in any missing assignments. Okay? So the last chapter is on measurement. Most of this stuff is fairly straightforward as we go through it. A lot of it will be done using formulas, which you'll be given. So some of the things we're going to be finding in this chapter is finding the area of different shapes, finding the volume and surface area of different shapes. When we talk about area, that's a two-dimensional thing that we're talking about. You can find the area of a piece of paper or of the top of your desk or of a floor or of a wall. Okay? When we get into surface area and volume, we'll be talking about three-dimensional objects. Things like prisms, pyramids, cylinders, cones, and spheres. So again, you'll be given all the formulas that you need for this chapter on a formula sheet, so you don't have to memorize them. You just have to know how to use them. And so basically you've got a copy of the formula sheet on that page. So we'll start by looking at imperial and metric measurements. So we're going to work with length. We'll measure items using both imperial and SI, stands for System International. That's your metric system. Okay, which is what we use most of the time in this country anyways. It never used to be that way always. Okay, Brooklyn, you with us? Earbuds out? Okay, when I was young in elementary school, we used the imperial system, okay, which is what they use in the US. And then when I was in elementary, somewhere along the way, Canada made the switch from imperial to the metric system, which most of the world follows. The only country that really does it now is the US. They still use the old imperial system. If you're ever down in the US and you're traveling on their freeways, distances are in miles, not kilometers, because miles is an imperial measurement. Okay, but pretty much everywhere else in the world uses the metric system now. The only difference is in construction. If you ever go to a hardware store and you look at lumber, it's still in the old imperial system, most of it. Sheets of plywood are 4 by 8, 4 feet by 8 feet. That's imperial. Pipe is measured in inches as a diameter. 1-inch pipe, 2-inch pipe, 3-inch pipe. 2x4s are approximately 2 inches by 4 inches. So the construction industry still uses the imperial system, but everything else is now the metric system. So let's see what we know or what we can learn about this imperial system, because it's not something most of you will be real familiar with. So we'll measure items using both systems. There are 4 basic imperial units of length. How many of them can you name? Put them in order from smallest to greatest. Well, the smallest one that we use in the imperial system is the inch. And then we have feet, we have yards, and we have miles. So those are the 4 units that we use with length in this system. And below you can see how they're all connected. There are 12 inches in a foot. There are 3 feet in a yard. Because there's 12 inches in every foot, 3 feet would be 36 inches. So that's why it says 1 yard could also equal 36 inches. There's 1,760 yards in a mile, or 5,280 feet in a mile. So these are some things that we'll be using to do some conversions. So the first example, where we want to convert each of the following. How many inches are there in 4 feet? Well, there are 12 inches in every foot. So 4 times 12 would give you 48 inches in 4 feet. To go from yards to feet, there are 3 feet in every yard. So if you have 5.5 yards, yep, yep. So if you have 0.5 in your calculator, if you go shift sign, there you go. So you got to put the decimal in first. So if you're using it as a fraction, let's say 12 divided by 28 is what the sine of theta equals. Whoops, I'm going to get 12 divided by 28 equals 12 divided by 28. If the sine of theta equals that, you put that decimal in your calculator first and then go shift sign. There's the angle. Yes? Do you have another question? Bring me a question on your book. Okay, so 5.5 is the number of yards, and there are 3 feet in every yard, so that's what we're multiplying by 3. So 5.5 times 3 is 16.5 feet. So if the sine of, so you're going to go 68 divided by 91 first. Get that decimal in your calculator. Okay, 68 divided by 91, and now go second function sine. There's your angle. Okay? Yeah. Okay, to go from yards to miles. Well, 1 mile is 1,760 yards. In this case, we have 4,400 yards. We want to know how many miles that is. So for some of these, you can do it by setting up a proportion. Because we're going from yards to miles, we will use this conversion up there. That shows the relationship between miles and yards. You have 1 mile is equivalent to 1,760 yards. So I've written a ratio there. And I've just decided to do miles on top, yards on the bottom. I could have flipped them around, it doesn't matter. But whatever order the ratio on the left is, the ratio on the right must be in the same order. Question C wants to know how many miles, so X miles there are in 4,400 yards. So we can find out what our answer is by solving this proportion. So again, I'm told that 1 mile is 1,760 yards. So that gives me my first ratio. I want to know how many miles there are in 4,400 yards. My ratio on the left is miles over yards, so my ratio on the right has to be miles over yards as well. And now whenever you have two ratios equal to each other, you can cross multiply. X times 1,760 equals 1 times 4,400. And now we'll get X by itself by dividing both sides by 1,760. So the 1760s on the left will cancel, and then we get X by doing this division in our calculator. 4,400 divided by 1,760 is exactly 2.5. Okay, so some of these conversions you can do just by going straight to multiplication. It just depends on what you're given and what you're trying to find. Others will have to set up these proportions in order to get our answer. People that work in the construction industry have to use a tape measure. So example 2 says, what is the difference from the beginning of the measuring tape to the arrow? So these numbers at the top represent inches. The numbers at the bottom represent centimeters. So we're talking about inches right now. And if you look, say, from 6 inches to 7 inches, which is the long line, right? The long line is 6 inches, the long line is 7 inches. If we count, we're going to see, if we counted them all, there would be 16 little increments there. Okay, and you can see there's different lengths of these little lines there. The shortest ones will be a 16th of an inch. And we know that because if you count how many increments there are from 6 to 7, there'll be 16 of them. So each one is 1/16 of an inch. All right? So this arrow here is between 8 and 9 inches. It's closer to 8 than it is to 9, but we can count how many of those short increments there are from 8 up to the arrow. There's 1, 2, 3, 4, 5, 6, 7. 7 of those small increments. Each increment is a 16th. So that would be 8 and 7/16 of an inch. Sometimes when you write your fraction, it can be reduced. In this case, it can't. You cannot divide 7 and 16 by the same value to reduce. Example 3, Tim is setting up a temporary fence around a building site. How many feet of fencing does he need for a site that is 31 feet 3 inches by 29 feet 8 inches to the nearest foot? Well, in this case here, we're talking about perimeter. It's the distance around the outside of an object. Okay, in that example, that small one on the right there, if you've got a rectangle that measures 5 inches by 2 inches, the perimeter can be found by adding up all 4 sides. There's 2 sides that are 2 inches and 2 sides that are 5 inches. So in this case here, we can find the perimeter of this fence, rectangular fence area, by adding up 31 feet 3 inches. So notice that one little tick mark after the 31 represents feet. 2 little tick marks after the inches, or after the 3, represents inches. So we have dimensions of 31 feet 3 inches and 29 feet 8 inches. But because we want the perimeter, it's the distance around, there'll be 2 of each of these dimensions. And when you do this, you need to add the feet first and the inches second. So we've got 31 feet plus 29 feet plus another 31 plus another 29. That's 120 feet. When we add the inches together, 3 and 8 is 11 plus another 11 would be 22. 3 inches plus 8 inches is 11 inches. Then you'll have another 3 and another 8 or another 11 gives us 22. But we can simplify this because there are 12 inches in a foot. So if we take 12 inches away from the 22, that'll add 1 more feet to give us 121 feet, and we'd be left with 10 inches. So there's our final answer. 121 feet, 10 inches is the perimeter of that building site. Yes.
I don't know if there's a square.
Sorry?
I don't know if there's a square option here because all these is cube.
It's right there. X squared is right there.
That's X squared?
X squared.
Oh, wait. I was looking at the second.
All right, so Julie wants to put a wallpaper border around the walls of her bedroom. The bedroom measures 10 feet 6 inches by 8 feet 9 inches. Calculate the perimeter. So it would be done exactly the same way. Now, you could, if you wanted to here, do it this way. You have 2 walls that measure 10 feet 6 inches, plus 2 walls that measure 8 feet 9 inches. Instead of writing out all 4 of them separately, okay, Shyla? You got some slobber on your chin there. Okay, so we're going to multiply the 10 feet by 2, which is 20 feet, the 6 inches by 2, which will be 12 inches, the 8 feet times 2 is 16 feet, the 9 inches times 2 is 18 inches. And what we could do here for 20 feet, 12 inches, well, 12 inches is 1 foot. So this 12 inches is 1 more foot, so we can say that's 21 feet plus 16 feet, 18 inches. And maybe what we should do right now, let's simplify that one, because again, there are 12 inches in every foot, so if we take 12 inches away from the 18, that'll give us 1 more feet, and it'll leave us with 6 inches when you take the 12 away from the 18. So now we'll add the 21 and 17 together and get 38 feet, 6 inches. That would be the perimeter of that room. That's the length of wallpaper that she would need in order to put that wallpaper border all the way around her bedroom. Right, so if she's going to buy wallpaper border, it'll be sold in usually a roll, and it'll tell you how much is in that roll, how many feet or how many meters. So it'd be important to know how much she needs so that when she goes to the store, she makes sure she buys enough. Karen's installing baseboard along the 4 walls in her classroom, and we've got our measurements there. 22 feet 5 inches by 18 feet 8 inches. But there are 2 doors, each 3 feet wide, where baseboards would not be installed. So what is the total length of baseboard needed? Draw a sketch. So we're going to draw a rectangle, but we have to leave space for 2 doors. And normally they wouldn't be on the same wall. Technically, they don't even have to be on opposite walls. You could have one on the length, one on the width. It doesn't matter. Right, so there would be a sketch of this. And remember, where we're told that the doors are 3 feet wide. So that's a 3-foot gap there. That's a 3-foot gap there. So if we say that the 2 doors are on the longest sides, which were 22 feet 5 inches, we'd have to take 3 feet away from those longest side. If we said that one of the doors was on the shortest side, or they both were on the shortest side, then we take the 3 feet away from the shortest dimension. It doesn't matter. You're going to get the same answer no matter what. But either way I've drawn it, the 3 foot where the doors are on the longest side. So if we take 3 feet away from the 22 feet, that would leave us with 19 feet and 5 inches. 19 feet and 5 inches. The widths haven't changed the same. That was 18 feet, 8 inches. 18 feet, 8 inches. So like we did before, let's multiply the 2 dimensions by 2 instead of adding up all 4. So 2 times 19 is 38 feet. 2 times 5 inches is 10 inches. Plus 2 times 18 is 36 feet. 2 times 8 is 16 inches. In this case, I think I'll add the feet and inches together first and then simplify. 38 and 36 is 74 feet, excuse me. And 10 inches plus 16 inches would be 26 inches. And now I will reduce this. There are 12 inches in every foot. So 26 feet is actually a little bit more than 2 feet, because 2 feet would be 24 inches. So if we take away the 24 inches from the 26, that adds 2 feet onto the 74 and leaves us with 2 inches when we take 24 away from 26. Okay, so there's our final simplified answer. Baseboard is sold in lengths of 8 feet and 12 feet. Give two combinations of baseboard that Karen can buy. So let's say that she's going to buy all 8-footers. She needs 76 feet 2 inches, which we would have to round up to 77 feet because they don't sell baseboards in increments of inches. It's either an 8-foot piece or a 12-foot piece. So let's round up the 76 foot 2 inches up to 77 feet, and we'll divide that by 8. And that would tell us how many 8-foot chunks she'd need to buy. Brooklyn, are you with us? So what's the answer? I don't think you're with us. That's how many 8-foot chunks she would need. Now again, you can't buy part of one, which means you'd have to round that number up. 9.625 would round up to 10. Ella, here's the booklet we're working on right now. Right there. So if she buys only 8-foot lengths, she'd have to buy 10 of them. Or what if she decided that she was going to buy the 12-foot lengths? So we'll take the 77 feet and we'll divide by 12 to see how many of those she would need. 77 divided by 12. Again, that number would have to be rounded up. 6.416 repeating, which we'd have to round up to 7 12-foot lengths. Now, there could be different reasons that would help make her decision on which length she's going to buy. One of them might be, well, she has to get them home. So does she have a vehicle that can take a 12-foot length piece of lumber? Maybe not. Maybe she has a smaller pickup or an SUV, and she can only fit her 8-foot pieces in there. Another thing to consider is, you're going to have to cut some of these pieces up. You want to try and do it so that you have the least amount of wastage. So that would be another thing that she would have to consider by doing a little bit of calculations to see which route would give her the least amount of wastage. Example 4 says a carpenter is framing the outside walls of a building. How many studs will he need to frame the walls? If he uses one stud every 2 feet. And there's a formula there to estimate the number of studs. And what you have to remember here is that you have to do it for each wall. If we look at the formula, it's the length divided by 2. And the reason it's divided by 2 is because there's one of those studs every 2 feet. So you know what a stud is, right? Normally when walls are built, there's a 2x4 on the bottom, and then there's vertical 2x4s. Those are the studs. And they're usually every 2 feet or every 16 inches, usually. And so then there's a 2x4 on the top. And then when those are all nailed together and stood up, then those studs is where the plywood or the gyprock goes on. The walls of the room are screwed onto those studs. Okay? So the reason you're dividing by 2 in this case is because we're going to have a stud every 2 feet. And the reason there's a +1 on the end is that for every wall, you must have a stud on each corner. That's why you're adding the 1 using this formula, because you must have 1 at each end of the wall. So these points here, there has to be a stud at each of those points, and then every 2 feet in between. And there will be some cases where, the lengths are not exactly divisible by 2 in some cases. So you might have one spot where the distance between 2 studs is a little bit less than 2 feet, maybe. That happens, right? But better to have too many than not enough, because it affects the strength of the wall. And again, you have to do it for each wall. You have to do the calculation for each wall. That's the way we're going to do it, and then we'll go back and see what we would get for an answer. Maybe I didn't put one on your desk, I'm not sure. Yeah. We'll see what you get if you did found out the whole perimeter of the room and then use the formula once. We're gonna see you'll get a different answer. So let's start at the top and work our way around. That top wall is 60 feet long, so it's 60 divided by 2 plus 1. 60 divided by 2 is 30, plus 1 is 31. So you need 31 studs for that wall. 31 of those vertical 2x4s. The next wall, 18 feet. Divided by 2 is 9, plus 1 is 10. Now notice that there is no dimension for this wall, so we need to figure out what it is, which isn't too hard to do, because if this bottom one is 24, the 24 and this have to add together to get the 60 above, which would be 36 feet. 36 and 24 gives us 60. So that's our next wall. 36 feet divided by 2, which is 18, plus 1 would be 19. Same thing, we don't have the length of this short little wall here, but we know that this is 18. This entire wall on the left is a 36, which means this one here also has to be 18. This 18 plus this 18 over here gives you your 36. So that's also 18 divided by 2, which is 9, plus 1 is 10. Then we have a wall that's 24. 24 divided by 2 is 12, plus 1 is 13. And the last wall is 36. 36 divided by 2 is 18, plus 1 is 19. So if we add all those up, we'll have our total number that are required. So 31 plus 10 plus 19, another 10, a 13, and another 19. So that gives us 102. That's how many would be required. Now, as I said, if you just added up the dimensions or the perimeter of the room first, add up the 60, the 18, the 36, another 18, 24, and 36. That's a total perimeter of 192. If we divide that by 2 and add 1, we're short. We're short 5 studs. And the reason for that is because using that formula, you're only going to get the studs, you're going to miss 5 of the corners. That's why we're short 5. So you'd be missing 1, 2, 3, 4, 5. You would only compensate for the one corner. So again, that's why you have to figure out each wall separately in order to make it work. Okay? So that's using the imperial system. So now let's go on to the metric system. This is a system we use in Canada. Again, SI is normally used. It stands for System International. And we talked about the fact that there are occupations that use both systems, especially those that are in the trades industry. They use both systems. So, like we did before, there are some units that we can list. The smallest one is the millimeter, and then the centimeter, then the decimeter, followed by the meter, then the decameter. Whoops. Don't talk back to me, Keen. And then there's the hectometer, followed by the kilometer. So some of these you're going to be familiar with. You've seen them before. But the decimeter, the decameter, and the hectometer are ones that we don't use very often. It's always millimeters, centimeters, meters, or kilometers. And you might remember some basic conversions. There are 10 millimeters in a centimeter. There are 100 centimeters in a meter. So you would have seen those before, so you should be somewhat familiar with them. And there are 1,000 meters in a kilometer. But we need a system so we can convert between all of these units, not just the ones that are used most often. And something that we can use to help us remember how to convert is something known as the metric staircase. Okay, so we can remember the metric staircase by remembering this acronym. An acronym is like a phrase that helps you remember something. So here's the phrase: kangaroo hates dingo because dingo can't multiply. So this is an acronym that can be used, known as the metric staircase, to help us remember how the different units in the metric system are related to each other. The K stands for kilo. The H stands for hecto. The first D, stands for deca. The B stands for the base. If we're talking about lengths, that'll be meters. If we're talking about mass, that'll be grams. If we're talking about capacity, that would be liters. But B stands for base. The next D will stand for deci, centi, and milli. The other thing we need to remember is that when you're going from a larger unit like kilos down to a smaller unit, your answer has to get bigger. Right? There are 1,000 meters in a kilometer. So as you go down the metric staircase, your answer has to get larger. And every step you take down the metric staircase, you're going to multiply by another factor of 10. Try this again. There are 1,000 meters in a kilometer. So if you have 1 kilometer and go down to meters, you're going to multiply by 10 once to get to hecto, multiply by 10 a second time, which is now 100, to get to deca, and then multiply by 10 a third time, which takes us to 1,000 to get to the base. And as you go up the metric staircase, you have to divide by a factor of 10 for every step you take up the metric staircase. So we can use this to help us convert within this system. The first one we want to do is we want to say 4.3 hectometers is how many centimeters? Well, to go from hecto down to centi, you got to count how many steps down you go. From hecto, you're going to go down 1, 2, 3, 4 steps down the metric staircase. And every time you go down the metric staircase, you're going to multiply by another factor of 10. So in this case here, you're going to have to multiply by 10 to the power 4. You're going to multiply by 10 4 times. Actually, let's first get rid of that. There we go. 4.3 times 10 to the power 4. Which can be done just by moving the decimal 4 spaces to the right. Every time you multiply by 10, the decimal moves to the right 1 spot. In this case here, we're going to move to the right 4 times because we're multiplying by 10 4 times. So moving the decimal 4 spaces to the right, we'd have to have 3 zeros on the end, and the answer would be 43,000. There's the answer. Okay? Question B, we're going from centimeters up to meters. So from centimeters up to meters, you have to go up 2 steps up the staircase. And every time you go up the staircase, you're going to divide by a factor of 10. So now we're going to have to divide by 10 twice. We're going to have to divide by 10 squared. And whenever you divide by 10, the answer gets small. The decimal moves to the left 2 spots, which means you'll have to have 1 0 in front of the 5 when the decimal moves to the left 2 spots. And your answer is 0.0562. And the last one, we're going from meters down to millimeters. So meters, which is the base, down to millimeters, it's 1, 2, 3 steps down. As you go down the metric staircase, you're multiplying by a factor of 10 for each step. So we're going to have to multiply by 10 3 times, or multiply by 10 cubed. So 6.7851 times 10 cubed, which means the decimal moved to the right 3 spots, which will be between the 5 and the 1. So 6785.1 millimeters. Okay? So on the next page, we've got some more to do, going from centimeters to meters. If you go back to the metric staircase, centimeters to meters is 2 steps up the metric staircase. So you're going to divide by 10 twice. We'll divide by 10 squared. And every time you divide by a factor of 10, the decimal moves 1 spot to the left. So this time it'll have to move 2 spots to the left, which will give us 0.4562 meters. So this next one, DK, stands for deca. I think I spelled it with a C. I should have spelled it with a K. So DK spells or stands for deca. I should have written this with a K. Whoops. Let's fix that. Okay, and this would be deca. Whoops, wrong one. Okay, so if we're going to go from decameters down to decimeters, you're going to go down 1, 2 spots, which means you have to multiply by 10 twice, or multiply by 10 squared. So it'll be 0.45 times 10 squared. Every time you multiply by 10, the decimal moves to the right 1 spot. So this one's going to move to the right 2 spots, and we're going to get 45 decimeters. To go from kiloliters to liters. So to go from kilo down to liters, you're going to go down the staircase 1, 2, 3 spots, which means you're going to multiply by 10 3 times. So it'll be 0.125 times 10 cubed, which will move the decimal 3 spots to the right, and we'll get 125 liters. And to go from centigrams to milligrams, you're going to go down the metric staircase only 1 spot, which means you're going to multiply by 10 once. So 1, 2, 5, 6 times 10 to the 1. We'll add 1 0 on that. It'll be 12,560. Okay? Example 7 says Janet loves making clothes. She's making 4 bridesmaids' dresses and a dress for a flower girl. She's using a pattern that gives measurements in metric units. She takes measurements and determines the lengths of the straps needed. The straps for the bridesmaids' dresses need to be 38, 38, 41, and 36 centimeters, and for the flower girl's dress, 25 centimeters. Remember, each dress would have 2 straps. How much ribbon does she need for all of the straps to the nearest hundredth of a meter? So, a couple different ways we can do this, but in this case, the dimensions are given to us in centimeters. And remember, there are 2 straps that are needed for each bridesmaid. So you'll need 2 straps that measure 38 centimeters, another 2 for another 38, 2 for the 41 centimeter one, 2 for the 36 centimeter one, and then finally 2 for the flower girl, which is 25 centimeters. So that gives us 76 centimeters plus another 76 centimeters plus 82 plus 72 plus 50. A total of 356 centimeters is what is required. But we're asked to write this to the nearest hundredth of a meter. So we now need to go from centimeters to meters. So back to the metric staircase we go. To go from centimeters up to meters, you're going to go up 2 spaces up the metric staircase, which means you're going to have to divide by 10 twice, or divide by 10 squared. And if you move the decimal 2 spots to the left, it'll be 3.56 meters, which is 2 decimal places to the nearest hundredth. Okay, question, the next one, we want to find the perimeter in centimeters. So basically you're going to add up all those sides. I'll just tell you what it is. It's 342 centimeters if you add them all up. But then we want to convert that into meters. So like we did before in the last question, to convert from centimeters to meters, you're going to divide by 10 squared. You're going to divide by 100, which moves the decimal 2 spots to the left. 3.42 meters would be the answer. Okay. Example 8, the distance from the ground to the top of the rabbit ears in the picture shown is actually 26 centimeters. So that's the actual height of the rabbit. What's that? But the picture, it's actually 7 centimeters. And the height of the miniature pig is 3 centimeters. What is the actual height of the miniature pig? So we're going to use a ratio for this like we did on the last lesson. All right? And I'm going to choose to do in the order picture over actual. I could switch them around. It doesn't matter. I just decided that this is the order I'm going to put my ratios in. And we'll start with the fact that in the picture, the height of the rabbit's ears is 7 centimeters, whereas the actual height is 26. So this establishes our ratio, our scale factor if you want. What is the scale factor between the dimension on the picture to the dimension that's actually there? All right, now we're told that the height of the miniature pig in the picture is 3 centimeters. We want to know what the actual height is. So I let that be x, and like we did before, we can cross multiply. 7 times x will equal 3 times 26, which is, I think, 78. 3 times 26, yep. So 7x will equal 78. And then we would divide both sides by 7 to get x by itself. And we're going to get a decimal here. It does say round to the nearest tenth. So that would be 11.1 approximately. That's the actual height of the miniature pig's ears. Right, this next one is the same type. The actual height of the adult elephant is 3.3 meters. The picture shows, if you measure on the picture, it's only 4.5 centimeters. And the height of the baby elephant, 2 centimeters. What is the actual height of the baby? So again, we need to establish an order that we will follow for both ratios. It doesn't matter. I could flip these around. As long as I do both ratios in the same order, that's fine. So the height of the elephant in the picture is 4.7 centimeters, where the actual height is 3.3 meters. And note, you don't have to, when you're doing this, you don't have to make them in the same unit. You can keep them in different units, as long as you follow the proper order for the other ratio. The picture shows the height of the baby elephant to be 2 centimeters. We want to know what the actual height of the elephant is in meters. So again, we would cross multiply. 4.7 times x equals 2 times 3.3 meters. And 2 times 3.3 is 6.6. And we would get x by itself by dividing both sides by 4.7. So 6.6 divided by 4.7 to the nearest tenth would be approximately 1.4 meters to the nearest tenth. Okay? All right, we'll stop there. I'll hand out assignments for 1 and 2. I would suggest that you do some of them. You don't necessarily have to do them all.